Leaky things are lazy. Sealed things are snappy.
Yeah, just coming off of El Mirage, the sharpness in like a highly tuned single cylinder engine, how sharp the sound cracks out of the tailpipe. And then you get into these muddy engines that they're just like, it's like a prop in mud. A lot of the stuff that we've discussed is the first time I'm ever getting it. So on one hand, I'm trying to take it in and let it make sense to my mind and be able to put it to use. And on the other hand, at the same time, I'm thinking like, holy shit, how cool is this?
When the engine's making power, it makes sound, it makes heat. The interesting thing is, like you said, so when you look at this, was it designed by the same person? I can look at different profiles and tell you they're designed by different people, or if it was a copy.
And on this lobe here, you have a small window of constant velocity. Is that what that is
so
right there?
You could, the constant velocity, you'll see it's right. Constant velocity would actually be the dip between the two accelerations, right? So in order for velocity to be constant, acceleration is 0. So these are the two constant velocities. So you just look at that point in between the acceleration, and that will identify where the constant velocity is at.
If you had an engine, and you're just spitballing, but if you had an engine and you ran those 3 different camshafts, how much, the other day we were talking about how many duration numbers equal a change in how the engine operates. So is this enough of a difference to have a measurable change in how the engine operates? Output at the tire.
The peak numbers will probably be the same as this steel one here that I used as the benchmark.
Okay.
But it will run differently. It'll just be cleaner,
crispier,
snappier, everything.
Okay.
Like the throttle response is like one of the biggest things that you see. Just real, everything's real snappy. Right.
Yeah.
Leaky things are lazy. Sealed things are snappy.
Yeah. No. Just coming off of El Mirage, the sharpness in like a highly tuned single cylinder engine, how sharp the sound cracks out of the tailpipe, and then you get into these muddy engines that they're just like, it's like a prop in mud.
It's funny, like the import guys, especially the Honda guys, were just so anti-domestic stuff, or and they still are. I mean, it's just a certain ignorance that has been pervasive in the import industry. I remember seeing the old school qualifying Winston Cup motors.
Almost inside the barrels, wow. Comes out of turn 11.
He was very low there.
Back second, third, fourth gear, right there at the start-finish line.
Like how the NASCAR used to have qualifying motors?
Yeah, short-lived.
they're 5-lap motors as opposed to their 500-mile motors. Unlimited qualifying motors. Man, the first time I saw one of those things at Sears Point, that's a fucking V8.
Oh, would you look at this?
Yeah, well.
Would you look at that?
Yeah.
It's like, doesn't sound like a V8. It sounds like a chainsaw.
Yeah.
Like I think the cleaner your engines are, the better they seal, the more power they make. They all start to sound like a chainsaw.
Yeah.
Buzzsaw on kill.
No, that's one of the neat things about going to a racing event that has many different engines that are all tuned well.
Yeah.
The sound changes.
Yeah. So yeah, just comparing the two, it's like I'm lower peak acceleration. He's 689. I'm 649. I have a lower closing acceleration because that typically makes things a little bit more stable.
So if you have if both cams are made out of the same material, is there a longevity advantage to either cam?
Well, this has got a bigger nose radius. This is a fatter cam.
So this cam, as the tappet is following it over the nose, more gentle.
Yeah, I mean, obviously, if you got the fatter the nose is, it's more gentle. It's gonna wear the nose.
And what were those numbers again?
280 and 285, and the other one is 242 and 250. Even though it's 50 thousandths to 50 thousandths, it's still so. By all metrics, this is a gentler cam than that cam, but it also has if we just kind of look at what the effective area is, this is kind of just the area under the curve calculation. They're about the same. So what's going to make the difference is the intensity numbers.
Okay.
All right. So let's see if we can see any difference. So for example, we can look at 400 lift, 72, 74. 350 lift, 106, 108. 130. So even though I'm the same size, I'm 2 degrees bigger, right? So at 300, I'm 134, 132, 157, 155, right? 155, 157. So with the same 50 duration number, I'm actually 2 degrees bigger. You know, I think the 300 and above number is probably more critical to how the engine runs.
Okay. Your target on lift was just to try to keep it in the same.
Same. I
No,
wanted.
no, I remember that, but you're trying to keep it in the same box.
I kept the 50 duration number and the lift number the same as the steel. That was the benchmark.
And if you needed to go further, how much is left in that bucket diameter? If you wanted to go further, if you wanted to say like,
I have to look, but it's close, but I think you can push the acceleration. This acceleration's pretty. It's not crazy. That acceleration's not crazy. Right?
Okay.
Like on the Honda K stuff, it's like around there. It's already higher by 15%. 3 zeros, 3 1.
and do you have to have that? Did you take that into consideration with the roller versus flat when it comes to acceleration?
We'd have to test it, but it doesn't. That number's not anything that I haven't done before in another engine.
Well, the more gentle radius on the nose is pretty cool. Like that's an
That'll
easy
help.
pickup.
Yeah. The chill cast is going to be the way to go, I think.
Well, that's kind of what most people come back to is the material loans itself for longevity, bad days.
Right.
Like there's a certain it'll smear around, but it won't just start to wad up metal.
Right.
And that one picture that we had where the steel has now rolled off the lobe, and it's just
it's the real simple the real simple analogy would be if steel with nitriding was a 4-inch slab, then chill cast is a 12-inch slab. You know what I'm saying?
Yeah.
Like EDC patio slabs are 4.
Right.
Standard warehouse slabs are 6. Right. You want to spend a little bit more, you get 8. If you want to, survive the Armageddon, then you do 12, and
bunker.
Yeah. So is that enough 2J fodder?
Well, yeah, because you'd like to build a better product that runs better. The snap and how much that crank rotation and valve event changes the personality of the engine. You said that it'll be snappier, which is a pretty big telltale of how an engine runs.
Oh yeah.
Like my big pushrod engine. Well, it's not big; it's 380 inches, but it is snappy. Like it is
I always listen to sound. Like I always listen to sound. Right. It's like when an engine's making power, it makes sound, it makes heat.
How much time from the time we get a blank?
Bug Brian. Say,
Yeah.
Brian, when are you getting blanks? I'm working on this project with Dave.
Yeah. I'd be excited to test it and to see if we can quantify a
So,
difference.
for example,
sure.
like if you told me, hey, I want to do 480 lift, or we have room to do 480 lift, I'm going to say, let's try 480 lift and let's push the accelerations a little bit more and then let's see what happens.
Yeah.
Brian said I asked Brian says his cores will do 460. So I say we do 460. I already have I designed a 460 cam first, and then I designed the 445 cam just to compare.
I brought a valve spring. It's in my car to leave with you, just to poke at it.
It's a lot of info on the 2J.
Yeah. Well, again, this is a lot of the stuff that we've discussed is the first time I'm ever getting it. So on one hand, I'm trying to take it in and let it make sense to my mind and be able to put it to use. And on the other hand, at the same time, I'm thinking like, holy shit, how cool is this?
Yeah.
That I get to learn this.
The interesting thing is, like you said, so when you look at this, was it designed by the same person? And I can look at different profiles and tell you they're designed by different people, or if it was a copy. And stuff. There's, especially on finger follower, if they take something like a flat tappet cam and they put it on a finger follower, and then you look at the valve motion, that other graph that I'm talking about, it ends up completely skewed. And that just tells you they grabbed a catalog grind out of some regrinder's book, put a symmetrical profile on there that wasn't designed for finger followers, or designed for finger followers with a totally different geometry. And then when you look at the graphs, they don't look like U-shaped. They look like a droopy U on one side. So when I see that, I'm like, oh, they copied, or they went to somebody that just has catalog like full of masters and said, let me try these.
Right.
And then see, that's the other thing is like
Can you define the term masters?
So on a manual cam grinder, it's like copying a key.
Okay.
But instead of a key, like on a key, you have the key and you go through the little things on the key, and it does the same on that. And you just use the key as the master, your original master. On cam grinding, they make the master plates about this big. And so there's a follower on this side that rides on this plate. And it's just like, why is the plate bigger? Is just because the bigger the plate, the better the resolution. The bigger the degree wheel, the better the resolution. Right? So they run a big plate over here, and then there's a follower that moves the grinding wheel. So this big thing is moving this thing in and out, and then the grinding wheel's a rocker table.
Okay.
Yeah. And so there's a plate master, and so like if you're designing a camshaft, you can go to people that make plate masters. There's different cam places where you give them the lift data, and then they go out and they machine you a master plate that you can put on your Berco or your Storm Vulcan or your Van Norman or whatever cam grinder that you're using.
Is this camshaft profile something that can be ground on a common large diameter grinder, or do you need to get in there?
No. This doesn't have inverted radiuses. So your flat tappet stuff doesn't have inverted radiuses.
Okay, so this is common stuff.
Yeah. I would be okay with other people grinding this profile, but they're gonna end up using it all over the place. So it's just really
yeah. Well, because injections of technology don't happen often. You got stuff that stays the same.
Yeah, well, this is
because it works good enough.
What we're doing isn't really technology. It's sort of like back to basics. So much stuff has been lost about stuff in general, and I don't think camshaft has ever really been addressed. People are starting to talk about it a little bit more. Like that. You ever watch Cam's old cam designer Billy Godball?
Yeah.
So he's talking about some stuff like. He trained under Harvey too.
Yeah.
So I used to see his name on the calendar. Calm. But I don't know. But I bet we have lots of things we could talk about.
Since he's retired, he sells classes. He sells time.
Does he?
You can book time with him.
Yeah, he's doing all sorts of stuff with EFI University.
Yeah, Ben Strader's place.
And doing stuff with Lake Speed with Total Seal.
Yep.
I like all those channels. All those channels are good.
Yeah. Huh. Okay.
Let's leave it at that.
Yeah.
We'll give you a copy of this stuff, and then you can ask more questions. And,
Well, it would be cool to have that diagram to just print it out and stare at it throughout some blocks of time. But it's cool to have
the comparisons.
the comparisons. Because is there a software or way that you could just overlay these different cam profiles in reference to crank degrees? Like the other day when we were messing with the B series, we were watching valve events where you could show um, valve position versus crank degrees and lay different cam profiles.
I don't have any software that'll overlay it. There is the cam measurement will tell you could load in your design file, and then it'll do your measurement file, and then it'll compare to see how accurate your grinding was. So
Okay.
That's available in the cam measurement software.
And in the JZ world, we've got a fairly small diameter bucket. How much, like you chase a bigger intake valve for set reasons. If you were going to chase a larger diameter bucket, is a millimeter worth the chasing, or should you go for 3?
I would go, if you're going to change the bucket, what can you fit in there? That's what I would go for.
Just go for the largest.
I would.
Does the bucket need to be captured 360 degrees? If it's not, if the cam lobe is going across the bucket from 12 to 6.
I think you always want enough material on the sides to support it, right? But then people cut the notch out for the big cams too. So
yeah,
so it's sort of like it's what Harvey Crane said: first rule of engineering is whatever works.
Right.
Like these K drag race engines. If I was to build these things according to what people tells me what works, I would never build these engines because they're already so far out of reasonable scope.
Oh yeah, when you get into those big cranks, they're pretty pissed off.
Yeah, 7,400 feet per minute piston speed.
Yeah.
And then they're spinning up to 11,000 RPM. After 10,000 RPM, the piston and the flame front and the pressure's running away. The piston's running away from that so fast, you just see the power just drop off.
Man, 7,400 feet per second.
And then the big pro stock motors, they're saying were like 8,100 feet per minute. It's even crazier, like 5-inch stroke stuff, right?
Yeah. Cool.
Daniel's ready for you guys on the Spintron.
Yeah, let's go check that out.
All right. Like, you pick it up, and then, you can ask your dumb question. He won't say it's a dumb question. He'll just be like, whatever. Yeah. And then move on. And so that was like a symbol that, I totally missed the mark because all I got was a whatever. Yeah. You have to ask the right question. You get a decent response. You ask the wrong question, it's sort of like, whatever.
Well, you also have to understand the teacher first. Like there's an old guy in my area that I'll go speak with him with a friend, and he'll walk out and he'll say like, what the hell was that guy talking about?
Agreeing on terms, it's just like the law. The first thing in any lawsuit or contract is defining terms, right? So it's like you have to define the terms, otherwise one person using jerk to explain velocity, the other person's using jerk to explain acceleration, the other person's using jerk to explain jerk.
Give me the tool. Come on. One at a time.
We're pretty much all looking at the same thing, but have our microscope zoomed in at different levels. We just have to get to the same level and zoom in together and zoom out together. All right, yeah, run it. Did you hear the resonance? At 85, went wah, 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 wah. So it's hitting some kind of resonance at 85. It's interesting. That could just be a wave resonance and not a spring issue. At 2,000 RPM, you can just see it just matches. That's your baseline over, or 7,000 RPM is matching the 2,500 RPM shape, so it's staying attached. And then as we start going up, you start seeing it separate here. And if it's too crazy, you'll start seeing the bouncing down there.
But that's real, where it's a little upset at the put down?
No, that doesn't look bad.
Okay.
It's like, again.
Do you have an example of one that's out of control?
Well, if the cam journal doesn't burn up, we can turn it until something explodes.
What'd you think, Jay?
I'm stuck on the sound.
Did you hear that?
The data is incredible, but just getting to hear, for years, my whole life I've been listening to engines. It's like when you're a little kid, the sound of an engine catches your ears, catches your attention, but they always have combustion present, so it's weird to hear. I've heard Spintron videos before on the internet, but to hear it in person is pretty wild. It's an incredible tool. You know how long you have to figure stuff out when you don't have access to a tool like this?
Oh, yeah.
You have to break a lot of stuff.
Yeah, we haven't even, we're just using it at its most fundamental, rudimentary levels, like stuff that you could see pretty obviously. When, those guys at Comp or whatever, I've seen their setups, God damn, you censored everything up for this winter, So that's cool. We just have, since they're not in business anymore, we're gonna have to start writing our own controls program at some point, I think, because they're not gonna support it forever.
Speaking on the cam grinder wheel, cam grinding is not something like is it a specialty type thing, or are there a bunch of cam grinders out there?
Well, there's a lot of manual cam grinders out there, but how many people can actually design it from raw measurements and numbers? Not many. Most of the places that do the manual cam grinding and the regrind stuff, they have a catalog full of profiles, but then you don't know what the geometry was for that associated profile, right? And that becomes really sketchy on the rock arm stuff.